Here we have the second slide in this, also, which is use case 14. And this is focusing on the image aspects. I said right at the beginning that imagery was a huge driver of big data. And that's particularly true in the defense area because they have so many sensors gathering so much data. And it says here they can get petabytes of data in a few hours. So that's because you have data which has high frame rate and is very high resolution. 1080p standard resolution from familiar from high definition TVs through these 10K by 10K pixel full color resolution images. And all of this stuff has to be put as one of these overlays, which I mentioned on geospatial displays. The images must have analytics applied to them, which are typically going to be probably machine learning analytics. And that's going to be able to identify objects. You know, the NSA and related agencies have been taking images and tracking the individual people and vehicles and buildings from those images for an awful long time. When I used to work in this field more intensively around the late 80s, we were doing exactly this problem. I used to work on how to do optimal pathfinding in complex terrains with multiple vehicles not interacting with each other. So that's a standard type of problem that we used to do. So being imagery, they're suitable for GPUs, and so somehow doing this GPU processing, also doing it in the right place. Remember, you have your sensor taking these high definition images. Is it really possible to put a GPU cluster near that sensor if that sensor is either in an aircraft or in a rather sensitive area where there's a lot of hostile action? So there's some very non-trivial issues here. And that comes back to this bottom. It says transmission of data from sensor to system is a challenge. The logical thing is to have the system in the cloud and then the sensor data out in the world and transmit from the sensor to the cloud. But it may not be possible. There may be too much data. So this is a very serious challenge in this field. How much processing to do locally and how much processing to do at the back end. Finally, we have for this defense area, the last use case is sort of the final step, which is supporting the intelligent decisions. This is actually called Fusion. We'll describe Fusion as an application on use case 16. And so you need to take this this is a classic problem. You have diverse data from lots of different sources. You have harried analysts and commanders and decision makers sitting either at their home, in front of CNN, or more traditionally in a command center with hundreds of displays around them. And they need to be able to make correct decisions. So a huge amount of processing is needed to just give the analysts the smallest amount of data possible to make decisions. It's easy to give them everything, but there's too much data. And as we get the bigger and bigger data, we're going to make better and better decisions as to what to present to the decision maker. So more analytics and intelligence is needed to make these decisions. So it says here, identify relationship between different entities, spot trends in sentiment or intent, find location and timing of hostile actions, including explosive devices, track the location and actions of the hostile actors, people, vehicles, and so on. Reason, think about what it implies and derive knowledge from diverse, disconnected, unstructured ED text sources mentioning an attack or mentioning a terrorist name. Process the data as close as possible to the point of collection to minimize data transmission, but at a point which is safe enough that you can afford to have enough computing. So these are serious challenges. And then we have the software, which involves standard NoSQL, big table software, Hadoop, processing natural language for the text data processing. We need Puppet, which does deployment and security. Storm is a Apache big data streaming software. And the data varies in size from tens of terabytes to hundreds of petabytes. With the image, which, as we pointed out, the imagery intelligent devices is gathering huge amounts of data. The actual warfighter on their own, first responder for the civilian crisis management application, um, would only have up to 100 gigabytes sitting in their handheld data storage. This data comes from wide different sources, both the civilian version and the military version, and you need to integrate this all together. That's this fusion problem. And it's actually a typical of the challenge of today's world, which actually today has made a lot of progress in fusing and integrating results from different sources and using some automatic analytics to make good decisions about how to do that fusing by using effectively the analytics to discover previous known correlations between data from different sources to find that same correlation in today's data and then what its implication is. So these three use cases have covered in three different steps, the aspects, the broad visualization of GIS and presenting of data in use case 13, the processing of the image use case and video in use case 14, and in use case 15, the fusion of the data to allow the analyst to make real decisions. So that's the end of this military area, and now we move on to healthcare and life science.